This is actually billed as the world's cheapest computer. Actually, this one is not as cheap as it would be as in the US, strangely enough. It's actually cost about $70 in the Czech Republic. This is the Raspberry Pi 3 Model B. It has a 1.2 gigahertz processor and a gig of RAM. And this one is made in Britain, which most of them have been. That defies the stereotypes of you have to make everything in a third world sweatshop to be cheap. In the US, you can get this one for about $35. And there are cheaper versions of it which go down to $5. So I suppose the $5 computer might be the cheapest computer in the world. It doesn't come with very much typically. You can order one for about $150 in this country with a monitor and a keyboard and a mouse and all that stuff. And then it costs about as much as a cheap PC. So it's actually not as good a deal as buying just the basic one, because you can hook this to some cheap monitor you have lying around or what have you. And the power supply is actually bigger than the computer, if you see this. Actually, this is not surprising because the power supply is the nicest power supply I've ever seen for a computer, because it comes with all of your international adapters. So it shows you there, EU generally, the UK, US, and Australia. The input on these is the USB-B, as on a smartphone. And it's actually, it's so cheap, actually, that you have to buy the casing separately. So there are a lot of choices of this. I bought a transparent casing that's sold in DatArt. Actually, not DatArt. This one was actually in Alza. I got this in Alza. And the reason I chose the transparent one is not only because it was very cheap, less than $10, but also because this whole project is meant to educate people about computers. So you could use a Raspberry Pi as your personal computer, but it's more something cheap that you can experiment with, and it's especially marketed towards the third world, actually. Because the idea is you don't just want computers that are cheap enough for the third world, but cheap enough to sacrifice for kids to tear apart, mess around with, and blow up maybe if they make a mistake, and not cost, a prohibitive amount of money. I also have some extra parts that the teacher lent me here. So I have a Bluetooth transceiver, which looks like nothing at all, but nowadays miniaturization is such that you can fit some pretty sophisticated stuff into just a tiny little box on top of a USB-A connector. And then I have a unshielded twisted pair Ethernet cable, category 5. And it's got RJ45 connectors on it, like most Ethernet cables. This is also borrowed. I'll see if I'm actually going to use it. I have another much longer one of my own that may end up being used. The project plan that I'm following right now may actually end up using Wi-Fi to connect rather than a cable. This Raspberry Pi, as I understand it, comes with a Wi-Fi transceiver. If it doesn't, I can get a so-called dongle for it that will plug into the USB port. And the Bluetooth is a backup plan for keyboards and monitors that can use Bluetooth, in case I can't dock it with my laptop, which will be the first choice. I have the receipts here, and the price in crowns for this was 1,647 crowns with tax, and the price of the power supply, which I had to buy, as I said, from Alza, but from a different Alza store, was 659. Actually, no, 329, because they billed it wrong the first time. 329 crowns. Yeah. One of the things about shopping at Owls is that you have to be aware that when they say in stock, they don't mean in stock. So you have to make sure it's in the store, because they make a distinction there to jerk you around. And getting the power supply required a little bit of effort, because at first they denied having it. But they eventually admitted, once their computer proved that they had it, that they had it. I looked it up on their website. And the next step will be looking through the correct plans and what else I need to get for this, and then unboxing. I'm keeping them in the boxes for now in case I have to bring anything back, but I don't anticipate it, because it doesn't look like there's anything wrong with it. And the Pi 3 Model B is basically the best one that you can easily find. Here I'm going to assemble the Raspberry Pi to the extent that I can. Basically, it's just a motherboard, and it has to be handled kind of gently. So we have the CPU, we have USB ports, USB-A ports, we have an Ethernet port, and an HDMI audio. This is actually the power supply, which is a USB-B. So you can use, in theory, a mobile phone charger for it, even though it also has its own dedicated power supply. Doesn't have a power switch though. It's switched on and off by whether you have it plugged in or not. The casing is an option. It's a kind of an important option though. It's the German instructions. I'm not sure what's up with that. We have to line up the ports, of course, with the holes in the casing. So you can see the HDMI and the audio go there, and the power supply there. Now it's starting to get complicated. Yes. This will go in here because notice that this has to line up. Actually, although they have German instructions, you can go by the illustrations. What I don't get, actually I'll admit, is, well, this is obviously the other side, because the bottom goes here. And the way you can tell how that goes is that it has to line up correctly with your micro SD. Actually, a shortcut to assemble it this way, without the board in it. So that side clearly goes there. This side would go here. You see the top would go on like that, but there's a catch. First of all, this has got a little hinge here, so that if need be, you can open it like that. Also, another detail. If I back on. Put that in reverse. This is in. I then have these ends, and the thing about the ends is that at one end you want the ports to be exposed. So what I don't get is why you would want this to not be exposed at this end. This end makes sense. Actually, this end, you want to have this fit like this. And the reason is, if you look in a second, as soon as I get this together. You need to get your SD card inserted there. And you might want to swap them. I think this is got a wrap on it still. This end is different because it has these USB ports. I'll reiterate that I don't fully understand why they would want it designed like this if it's going to block the ports. Now this looks like a crack, but this is in fact not a crack because that is laminate. I don't actually know why they laminated that. So I suppose if you wanted to block the ports, you could put this on. Except you don't want to block the ports. Necessarily. I think what I'm going to do is I'm going to leave this part off because I want these ports on this end to be exposed. Now, there it is anyway. So it's assembled, and the way it would work is if I were going to run it right now, I would plug the mobile phone cable in here. Like that. And then I would plug that in. But I'm not going to because actually there's nothing in this. And another thing, another important detail, I have another SD card. So this also will be removed when I'm done with the demonstration here. Because I don't actually have any software loaded on this yet, because as you can see it's brand new. But just to show how it will fit, the way this will fit is like this. So the little push. That's frustrating. That's lined the wrong way. I wonder. Okay. There we go. Okay, so that's why it wouldn't work the first time. So just like on a mobile phone, it goes in like this. And some people have commented that just because it doesn't click doesn't mean that it's not in, because it is actually in. Because this one isn't spring-loaded. Some of the ones on the mobile phones are, but on the Raspberry Pi that's not the case. actually. Yeah, now this explains partly why this is open on the bottom, but it's easier, I think, if I want to get it out, to simply cheat. Yes, definitely I'll cheat. Of course, another way of looking at that, not laminate again. I can get the laminate off while I'm at it. And find it. I can feel it. No. Maybe not. Ah, there it is. Okay, I'm going to take a look at the Raspberry Pi hardware here again. Now that it's assembled in the box, I can hold it a little bit better. So I mentioned earlier that this is the CPU, but what I also mentioned was I couldn't find the RAM. The reason is the RAM is in the CPU. Also, the other processing functions like graphics and floating point are also integrated into the CPU. This is actually the Ethernet card. So this is basically the electronics behind it. Basically, it's like a network interface card, although it's not removable. And there's the actual Ethernet port. I mentioned earlier this is a headphone jack, although actually this is an AV jack. So it's 3.5 millimeter, but it's the kind that you would have on a lot of maybe late 90s, early 2000s video cameras, where you plug the 3.5 millimeter in here, and then you get 2 to 3 RCA outputs. So one or two of those are sound and the other is the video. There's the HDMI port as mentioned earlier, and the USB-B, which is only for power in. These are the USB-A ports, which arguably are a better offering than what you can find on a lot of laptops and pretty much anything by Apple nowadays. There's the RJ45 port for the Ethernet mentioned earlier. It's got some power lights on it, which is nice. I've never had one like that. Then if we look inside, it's actually it's very hard, it's not kind of hard to see. Actually, I better set up the camera differently for this next shot. That's their Wi-Fi transceiver. Absolutely tiny. Very, very hard to spot. But much smaller also than the wired Ethernet networking card, which I presume is actually linked into it, actually. Another part that I got wrong the first time when I was trying to find it. We look very carefully here. Here we have the bunch of integrated circuits here, and if you look very carefully, this here, which I have the screwdriver against, that is the voltage regulator. And it makes sense to have it there because the USB-B port is there and that's used for the power input. The reason for that is that it's a commonly believed myth that the Raspberry Pi runs on 5 volts DC. It does take 5 volts input, but like a lot of computers, that's not the actual operating voltage. It actually operates at 3.3 because it's, it's small. But computers generally, even if their power consumption can be very high, frequently run at much lower voltages than a typical appliance. Raspberry Pi has some other connectors which are unusual for a computer that's nominally a PC. We get the right angle here. One of the notable features is this. It's kind of hard to see because it's in the corner of the box. You have the slot here in the casing for it. And what that is, that's what's called a DSI connector. And a DSI connector, this is a better angle. A DSI connector is actually a display connector, but of course typically if you were going to connect a display to the Raspberry Pi, you'd use the HDMI, probably. Maybe the AV. The AV is sort of a backup. And the problem with an HDMI is that typically it won't work with a mobile phone touchscreen. So this is, as I understand it, the reason why the DSI connector was included on the board. A similarly unusual connector to see is the CSI. This is typically used for a webcam. And again, the reason I say unusual is that you don't actually need this most of the time for a computer because a typical webcam will plug into your USB, typically. And a lot of course, Raspberry Pi users are security conscious and they don't want to have the camera plugged in all the time anyway. But that's what you would probably have internally in a lot of PCs that have the built-in webcam. And I shouldn't conclude until I include a quick description of this here. This is a GPIO connector. So if we look carefully, it says GPIO. That's this. And each of these pins does something completely different. There you can get maps of these online explaining what each of them does. And it's very complicated actually because of the different combinations of things you can connect to this. It isn't designed for any one connector, but basically to be connected to individual jumpers for each pin for operating robots and Internet of Things and basically any kind of, interesting science project you want to do. And it means also that you can use the Raspberry Pi for much more ambitious projects if you want. Basically, an Arduino, if you hear of an Arduino, is a much simpler version of this principle. It also has a GPIO connector. But the only thing that an Arduino does is run programs to operate robots and Internet of Things and so on. Whereas a Raspberry Pi is basically a full-fledged PC, as I've said before. So you have all this other stuff, like the processor and everything I've described so far. So it's not an Arduino, and an Arduino is not a Raspberry Pi. But this particular feature is very rare on a conventional, Windows PC. It's one of the few things that a Raspberry Pi has that really, irrespective of price, makes it different from a PC. One final part that I should talk about, because it's often in diagrams of the Raspberry Pi, but rarely used. If we look carefully at these two holes here, again, I'm having a little bit of lighting problems here, but you see these two holes that don't appear to be connected to anything. And in fact, you would be right. They are not connected to anything, and that's the whole point. It says run next to it. That's deceptive because it's not what it's for. What happens is if you connect these two holes somehow, it resets your Raspberry Pi, especially from the standpoint of the processor there. And I checked online for information about it, and a lot of people just say that it's of questionable use, because essentially it's a very crude way of resetting it and can lead to your SD card there being corrupted. And of course, as I mentioned in the assembly, the SD card port is used essentially as your hard drive, because it's too small. This computer is basically too small for a hard drive. So you put your operating system on your SD card in theory, and all your important stuff there. Because, it can hold 32 gig, 64 gig. It can take up to a 64. I have a 32. And you don't want to corrupt that, because obviously you then have to rebuild it, and you might have had some important data on there. So although you have that run thing there, a lot of people don't think it's very useful. But it's worth mentioning because it's in a lot of diagrams.
This is Balena Etcher, which is a popular SD card flasher. This was a favorite for a number of years for Raspberry Pi users because you could flash a Raspberry Pi system image, generally a Raspbian image, to an SD card that you could then use as a bootable drive on the Raspberry Pi. And it had the advantage that you could try other operating systems beyond Raspbian. Pretty much anything compatible could be flashed to the drive. And there's nothing wrong with it. I haven't heard anything negative said about it. What can be said, though, is that it might be even easier to use the new flasher developed by the Raspberry Pi Foundation. So this is the new Raspberry Pi SD card flasher, or Raspberry Pi Imager. It's already on version 1.5 because it was introduced earlier in 2020. And if you choose an OS, this doesn't have to mean that you already possess an image. I'll show you why. So they give you some basic. If you go to Raspberry Pi Other, clarify that. This is a very basic Raspberry Pi, or in the old days they would have called it Raspbian installation. So this is the default that I just accidentally clicked. But these are the other ones. And as it says online, so you can, if you want, not have the image even on your computer taking up hard drive space. This one is cached because I've used this one before. So I have a cache on my computer of this particular Raspbian or Raspberry Pi OS installation. This has all the recommended applications, including Minecraft Pi, which is not exactly the same as any of the other Minecraft distributions, simply because Minecraft, as crude as it is a little bit demanding for a Raspberry Pi. So they've stripped it down so that it runs a little bit better. It's still in beta, last I knew. I've only tried it once, and that was beta 1. It's now up to beta 6 at last report. So, anyway, jumping back. Here you can put in Ubuntu, and you have choices of Ubuntu. You can use the regular Ubuntu desktop, which is new, by the way. They didn't actually offer this in the earlier versions of Raspberry Pi Imager, although it only is compatible with Raspberry Pi 4, which includes the 400. It's a little bit too demanding for an older Raspberry Pi. And the Ubuntu server has always been an option. So they have several different versions of it here. The Ubuntu core only includes the command line interface. It's very, very basic. Then you have RISC OS Pi, which I don't know a whole lot about actually, but it is compatible with a wide range of Raspberry Pi models. You can use libralec from Kodi as well, which is for a media server. And they also have RetroPie and recalbox, which are basically emulators. And TLX OS, which I know very little about, but it's basically an alternative to Raspbian, although it's only a trial. That's actually payware, which is unusual for Linux. And then you can get a boot recovery disk. And you can just flash a drive, just delete it if you want. But then you also have the function that you would have in Balena Etcher, where you just take an image from your hard drive and... why is this fighting me? There we go. You could just take an image from your hard drive and then flash it to an SD card. And actually, if you're only working with a Raspberry Pi, it could be argued that you don't need any other SD card flasher but a Raspberry Pi imager. But I have Balena Etcher anyway as a backup, just in case I would ever need it. But today, I'm going to create a bootable SD card. And the reason I'm bothering to do this is that I have a little trick that I have to show you. If you're ever going to be using a Raspberry Pi without a keyboard and monitor to plug into it, if you're going to dock it with your laptop or your existing PC, although if you have an existing PC, you probably have a keyboard and monitor. So let's say if you're a laptop user only, it can be a huge problem getting into it. And when I was shown by one of my professors, actually, how to use a Raspberry Pi, they completely omitted this, and it wasted days of my time trying to struggle with online tutorials that mostly didn't tell you how to do this. So this is not the only tutorial on YouTube which will show you how to do this, but I'm making a point that I'm going to be one of the few people who actually show you this, because it's actually quite important for the people who don't have a keyboard and monitor to plug into the Pi. The main reason is you can't really configure the Pi or use it at all without a keyboard and monitor unless you do this. So here we go. I'm going to plug in to my card reader a blank SD card, 32 gigabyte, and I'm going to select the existing full install of Raspberry Pi OS with the recommended applications. We choose the SD card. This is the only SD card I have plugged in, so we'll use that one. And then we write. And this can actually be a little bit time consuming. SDHC card will be erased. It's a completely new card. I have nothing on it, so yes. I'll probably skip over this process because basically it goes through preparing to write, writing, and then verification, because it does automatically verify your SD card, which is nice. But this video will be clipped because this is a waste of time just to watch this for the sake of watching it. From here we go to My Computer or This PC, depending on which Windows version or configuration you're running. And we have the boot drive, the DVD. We have the Linux partition of the SDHC card. And it says, of course, it's incompatible. Don't format it. Ignore all these errors. This is really what you want. This is the FAT format drive, or partition, really. So it serves as the G drive, and it doesn't even explain this to you very well. You can see it says FAT32 there, to be fair. So it's a FAT32 partition. And inside the FAT32 partition, you have the various files used in setting up the Raspberry Pi. And you have to add a file to this so that you can access the Raspberry Pi with SSH with no setup. Very important, because if you can't do that, you basically can't get into it without a keyboard and monitor. So we will do that now, going to the Windows command line. In Linux or Mac OS, you would use the terminal. The Windows command line is officially called the command prompt. So first of all, we change drives. This is done the same way as in DOS. I was confused by this earlier, but it is really G : to go to the G drive or G partition, just like in DOS. And then we put in this PHP-like command. I didn't know that you could do this at the Windows command prompt, so I guess you learn something new every day. Echo, arrow, this is very important, or the greater than, less than sign. The arrow, if that's the right word, would be pointed to the right in this case. /SH, then return. And it looks like it didn't do anything. But if you go back to the drive, here is our new file. Now, if I open this, it just says SSH. It doesn't have any suffix. I have to open it with a text editor. We'll just use Notepad for simplicity. And here you can see Echo is on. That's all it says. But this simple file will configure the Raspberry Pi at setup to use SSH. If you're running the Raspberry Pi headless, you're not necessarily going to know the correct MAC address or IP address for it. Generally for VNC and SSH, you need the IP address. So I have here Advanced IP Scanner, which is a pretty popular IP scanner for Windows. All of this is kind of presuming your main computer is Windows, because most people's computers are. But there are similar programs certainly for Linux and Mac OS. So if we run a scan, usually isn't instantaneous. This will show you the IPs of all the devices connected to your network, not just directly to your own PC that you're working from. So it's 192.168.0.102. Now, this is the Windows command prompt. Many people who access servers and other computers by SSH use a program called PuTTY, which is very popular. But what not everybody knows is that you can just use the Windows command prompt. You don't really need PuTTY to do a very basic SSH connection or a telnet connection. You can use it for telnet also. So you enter SSH, switch L. Apologies for the sloppy typing here. The username, and then the IP address we saw before, 192.168.0.102. 0.102. Then it warns you, well, we've never seen this server before. Well, sure enough, it's brand new, right? So if you're sure you want to continue connecting, yes. Then it adds it to the list of known hosts. And if we try to log in to the same IP with the same username, but a different host in the future using the same IP, it won't let us in. We'd have to delete that from the list of known hosts. It's a security feature in Windows. Now that we'll put in the default password for the Raspberry Pi, which is Raspberry. Always want to change that once you're going to do any kind of serious work with it, because everybody knows that and it's totally insecure. But this is the first time, so put in the password, return, and we are in. And they say use Raspbian config to set the country before use. We actually have to go into the interface options for our VNC. So select yes. Now it's all set. So this VNC server is enabled, meaning really we can just access this via VNC. Because it's asking us to set the regional settings, we might as well just do that. I wasn't originally planning on that, but why not? So locale. I wish it would just be a little bit more straightforward with us here rather than giving us codes here. Well, I am in the Czech Republic. Probably makes sense to set it for Czech Republic and UTF-8, I think. We'll change this later if we have to. Great Britain, UTF-8, or simply... Well, we'll start with the British. It's a British computer, right? So it's setting it up. In honesty, I've always used a graphical user interface for this. I've never actually tried to do this way, so you'll see me make a mistake if we have to go in and fix that later. Now, I don't think there's anything else we have to do right now. So if we finish, puts us back at the command line, and I'll exit out of this and we'll try VNC. Now we're in VNC here, and you can see that I have some other projects here already existing in it. But if I try a new connection here, the IP address is 192.168.0.102, as stated earlier. Double check my options here. I think everything's correct. So we attempt now to connect this. So no record of connecting to this VNC server. Well, the reason is a brand new Raspbian installation. And they give you these catchphrases and signatures. None of this is going to be relevant over the long term. This is why I'm letting you see it, because this is simply an experimental machine that's going to get flashed when this is over. So the username is Pi. As I said before, you want to change the password if you're going to use anything long term, but the default password is Raspberry for all Raspberry Pis. Never leave it at that if you're going to actually use it for anything. And we're in. There we go. And they're reminding you the default password has to be changed for security reasons. Again, I'm not going to do it because this Pi is basically disposable. I'm going to go a step further here, and I'm going to resize this. This will require a little bit of video editing. Okay, so we're in the Raspberry Pi, and they want to set it up for us, or help us set it up. Not too automated. Why does our screen look so horrible? That's a question. maybe we can fix that in configuration. So next. Now, country is actually Czech Republic. I mean, if you follow my channel, you know that I'm based in the Czech Republic. So we'll jump up to the Czech Republic. But I'm not actually a Czech speaker, and they have this checkbox that you don't have to go with the different varieties of English. If you're living in a non-English speaking country and you want to use English, you want to use the US keyboard, which I might as well, you can check those boxes. Next. Setting location, please wait. This will handle the time zones and so on, because notice we've got GMT, well, I mean, you wouldn't know actually, but that was GMT time. Just switched over to the Central European time because of our changing the settings. I'm going to skip this just because it's inconvenient, but obviously you do want to do this step if this matters to you at all. And I think they don't even let you skip it. So I'm going to stick with the default. As I said, this computer or this installation is going to be disposed of after I'm done with the demonstration. I'm not going to put anything on this one of any value. And does this show a black border around the desktop? Well, in VNC it does. So I'm going to check that box. It will attempt to correct it. Now it's actually going to try and configure the Wi-Fi. This is actually an advantage that Raspbian and Raspberry Pi OS have over, for example, the original Debian. The original Debian has a lot of trouble with Wi-Fi, at least in its current version. And I'm actually working on that as one of my other projects to figure out the best options for running a Debian box on Wi-Fi. But Raspberry Pis don't have any problem with Wi-Fi. Generally, they have all the drivers they need and everything else, but we're not going to use Wi-Fi this time. So we're going to skip this. And then they're going to run the automatic updates. We might as well. We're connected via Ethernet to the internet, albeit with some precautions. And in my experience, Linux boxes generally, Raspberry Pis included, update much, much faster than Windows PCs. I don't really know the reason for that, whether it's a software advantage or whether it's a case of them having better servers. I don't actually know any of that. This is a pretty current version of Raspberry Pi OS, aka Raspbian, so there probably won't be too much to update. That is my prediction. There we go. It's finally starting to respond here. Worried that I had a networking problem there. But as I said, contradicting what I just showed you, Linux boxes generally update pretty quickly and pretty efficiently. But in any case, it looks to be zooming along with the updates here, so I'll do a little bit of work on the Raspberry Pi itself and see if I can clear up this image. That little hairbreadth of a weight still to go here. Frustrating. Okay, system is up to date. That's okay. So they're saying we should restart. I guess there's no disadvantage in that, but I'm going to do it later because I want to take a look at these graphics. Okay, so that's much better. This is actually looks decent. So I guess we can continue the tour here. So we have, for programming, we can use any of these IDEs. Scratch is something kind of different if you've ever used that. Mathematica is more of a Maple-like math program. So you have various different programming and hacking tools here. Education, they just have SmartSim. Then they have the LibreOffice Office Suite, which is also pretty typical of a full Debian installation. It's not just something you get in Raspbian. I've actually featured it in one of my other videos on building a Debian live flash drive. Your default web browser is Chromium. You might not like that. You might want something a little bit more secure. Comes with Clausmail. Again, you might want Thunderbird. Comes with VLC Media Player, as I said earlier. You have this image viewer. I don't know how good that is. I guess it's just a basic image viewer. And then you have games. The only one of these I know is Minecraft Pi. As I said earlier, I've played Beta 1. I think it's up to Beta 6 now. That's confusing because it's related to Beta 6 of Bedrock. And then you have utilities. They say accessories. It's really utilities. You see what I mean there. You have help files also, although they're Debian for the most part. And the preferences, as I mentioned earlier. You can fiddle around with your system. And you have add and remove software, a graphical user interface. And you have the run command. And you have the logout. You can't really shut down a Raspberry Pi from Raspbian because they don't have an on-off switch. They don't go on and off. You either plug them in or unplug them. Although it's probably a good idea to do the proper logout procedure before pulling the plug, just as a matter of common sense. And then I guess the final thing to look at is you have Bluetooth here. I should turn it off, actually. I shouldn't have Bluetooth on. It's a security risk, and I'm not using Bluetooth. Wi-Fi is there. We have Ethernet configured, actually. Even though this is also the Wi-Fi, if you click this with the left click on the mouse, it is the Wi-Fi. And then you have the volume control, and you have your clock, which gives you the calendar if you click on it. Left click on it, mind you. So I guess that's the tour. We'll move on to our projects next, I suppose. I might do a Minecraft Pi playthrough too. I have to decide on that. In any case, thanks for watching, and thanks for watching my longest single-part video ever.